Very good morning, students, and welcome to the digital classroom of General Science. Dear students, today we are going to start with the lesson number 19, Life Cycle of Stars. And students, once again, I am requesting you, please keep your workbooks and journals complete. Don't keep the work pending. Whenever the workbook exercise is sent, please see that you complete the books. Okay. So now let's start with lesson number 19, Life Cycle of Stars. Students, what do you see on the screen? Do you have any idea? These are the different galaxies. Now, in the previous class, we had studied about our solar system. Our solar system is present in a galaxy. And what is a galaxy? A galaxy is a collection of billion of stars, their planetary systems and interstellar clouds which are present in the empty spaces between the stars. Our universe is made up of such innumerable galaxies. And the galaxies, they are different in structure and shape. Mainly, they are divided into three types: elliptical, irregular, and spiral. Now, these names are given on the basis of their shape. Now, our Earth, our galaxy rather, it is a spiral galaxy and it is called as Milky Way and Mandakini. This is the name given to the spiral galaxy in which our universe is present. So, the Milky Way and Mandakini is we. We are present in this. Students, do you know how these celestial bodies which are present in the space, how they are studied? How do we get the information about these components present in the universe? They are studied with the help of the telescopes. You can see the pictures of two different types of telescopes on the screen. The first one is the telescope which is present in the space, which is sent in the space, and it orbits the Earth. And as it is situated above the Earth's atmosphere, it can observe the different astronomical objects very effectively. And the second one is about the telescope, which is used from the land to observe the sky. Such telescopes are used by the different scientists or by the different people who study about the stars or who study about the different celestial bodies. Students, when we stare at the sky at night, we see thousands of stars with our naked eyes, and our sun is also a star. Sun is called an ordinary star. Why? Because there are stars which are much bigger than our sun and have much high temperature than the sun. But the sun is much nearer to us compared to those billions of stars which are having bigger mass, which are quite bigger in size than the sun and are having much high temperature than the sun. Now, these stars are big spheres, gigantic spheres, and they contain hot gases. Now, if we study about the sun is made up of 72% of hydrogen. You can see the green color that represents hydrogen, and thus this hydrogen is around 72%, and helium is about 26%, and the 2% is of other elements which are heavier than the helium. Then the properties of the sun. The properties of the sun is 2 into 10 raised to power 30 kg. Its radius is, you have to count unit, tens, 100,000, 10,000, lakhs. 6,95,700 kilometer is the radius students, right? Then the temperature of the surface is 5800, and in the center, the temperature at the center is 1.5 into 10 raised to power 7 Kelvin, and surface temperature is 5800 Kelvin, and the age of sun is around 4.5 into 10 raised to power 9 years. These are the properties of the sun. Now there is an information given in the textbook. Do you know? The masses of other stars are measured with respect to the mass of the sun. So the other stars are compared with the mass of the sun, which means that the mass of the sun, written as capital M-S-U-N, that is sun, is used as the unit of mass. Right? Did you get it? That the mass of the sun is used to compare the mass of the other stars. Right? Then, how to compare the sizes of the different stars? As you can see in the picture, students, the sun, right, that is compared with the mass of the other stars. So it is used as a unit. And you can see the red dwarf, that is a small star. You can see the blue-white supergiant. You can see the size. You can compare the size of the sun with this blue-white supergiant, right? So it is 150 solar masses. That means it is 150 times it is having mass compared to the sun. And below you can see the red giant star, which is a very old star, and it has evolved from the stars of less than 5 solar masses. So you can see that the stars are of different sizes, and the unit of mass is the mass of sun, that is represented as capital M, sun, and it is used to compare the mass of the other stars. Then a very interesting topic we have to study is birth of stars. How the stars, they are born. Now, the birth of the star takes place through the process. The huge clouds of gas and dust, they are present in the empty spaces in the galaxy in between the stars. Now, these are called as interstellar clouds. Now, you can see the picture of interstellar cloud on the screen. Now, students, the scientists, they use the unit of light year for measuring large distances. So, light year is the unit which is used to measure the large distances, and a light year is the distance traveled by light in 1 year. And the speed of light is 3 lakh kilometers per second, and the light year is almost equal to 9.5 into 10 raised to power 12 kilometers. And you know the size of these interstellar clouds are about a few light years. And what is a light year? Light year is the distance traveled by light in 1 year. So we can imagine the size of the interstellar cloud. Now, what happens Due to the disturbance, some clouds, they start contracting. They start contracting, that is, as their temperature, it starts increasing, the size contracts and it becomes a dense sphere of hot gas, which is called as cloud. Now, once the temperature and density at the center of the sphere increases, the nuclear energy, it starts generating. Now, due to this energy generation, the gas sphere, it becomes self-luminous. It starts giving out light and the star is formed, or we can say a star is born. Now, inside the sun, this energy generation takes place by the fusion of hydrogen nuclei. As we had seen that almost 72% of sun is nothing but hydrogen. And this hydrogen nuclei, it fuses to form the helium nuclei. And thus, the hydrogen at the center of the star, it acts as a fuel. The hydrogen, 72% of the hydrogen which is present in the sun, it acts as a fuel and the energy is generated by the burning of this fuel. Now, more than one stars can also be produced due to the contraction of these large interstellar cloud. It is not necessary that only one star will be formed. The gigantic interstellar cloud, it can form n number of stars. Then we have to study about the stability of stars. Now I'll give you one example. Now, how these stars are stable? These stars are nothing but they are the spheres of hot gases. Now we know that the hot gases, they disperse very fast. Very simple example I'll give you. When we burn the incense stick, agarbatti, what happens? If we burn it in one corner of the room, the fragrance spreads in the whole house, right? Why? Because the hot gas or the hot air spreads very fast, right? Now, when we say that the star is also a sphere of hot gas, then why this gas does not disperse in the space? This question arises in your mind? Yes? Now, this does not take place because of the gravity, because of the gravitational force. The gravitational force between the gas particles of the star keeps the stars or these particles together. Now, this gravitational force which tries to bring the gas particles close together, the pressure of the gas, it has a high pressure also, it also tries to disperse the gas and thus it is balanced. Now, it has a very high pressure and it has a high temperature. Now, because of high temperature, the gravitational force keeps the gas particles together, but on the other hand, the high pressure, it tries to disperse the gas particles and these two, they balance each other and due to this, the star remains stable. So, this gravitational force, it acts inwards towards the center, right? And whereas the gas pressure, it acts outside, that is outside the star, and thus the stars, they become stable and the stability of the stars is maintained, right? As you can see in the picture also, due to the gravitational force, it works to the center of the star and the gas pressure works towards outside of the star, and thus because of these two, the balance is maintained and the stars, they become stable. Okay. Now you have to understand this, that if there was no gas pressure in the sun, it would have collapsed within 1 to 2 hours. But we have studied that the sun is as such since last almost 4.5 billion years, right? Now this gas pressure depends on the density and the temperature of the gas. Higher the temperature and density, higher is the pressure. Now we will see how the stars evolved, the evolution of the stars. What is the life cycle of the star? Now, as you can see in the picture, these are the different stages in the life cycle of the star. Now, we had studied, as I said, that sun has not changed since last many billion years, right? Now, how they remain stable? Now, as I explained in the previous picture, that to remain stable, they have to maintain the pressure, maintain the balance between the pressure and the gravitational force. Now, to maintain this balance, they need the temperature to remain constant. And when the temperature remains constant? When energy is generated inside it. Now, how the energy is generated? The energy generates because of the burning of the fuel, that is hydrogen, and it takes place in the center of the star. So the evolution of star is because of the burning of the fuel, and when the fuel in the center decreases, the energy generation stops. Now, when the energy generation stops, the temperature of the star starts decreasing, right? There is no energy supplied, so the temperature starts decreasing, and due to this, the gas pressure and the gravitational force also decreases, and the balance is not maintained. We had studied that the stars are stable because of the balance maintained between the gravitational force inwards and the pressure outside, right? But if this balance is disturbed, then the stars will not remain stable. Now, when all the possible fuels which are there inside the star, it is exhausted, the energy generation completely stops, and the temperature of the star, it also starts decreasing, and slowly the balance between the gravitational force and the gas pressure is disturbed, and due to this, the stars, they move towards their end stages. Now, there are three ways of evolution of stars depending on their initial mass. So, we will divide, it is divided in three groups. The end stages for all the stars in the same group is same. Now, first one is the end stages of stars having initial mass less than 8 times the mass of the sun. They are less than 8 times the mass of the sun. Now, stars which come in this group, they undergo huge expansion and their radius increases by 100 to 200 times. And at these times, in this stage, they are called as red giant stars because they look very much reddish and they have a very low temperature and their size becomes very big. Thus, they are called as red giant star. Now, at this time, these stars, they explode and their outer gas envelope is thrown out, and the inner part contracts and its size becomes almost similar to the size of the earth. Now in this state, the star looks white, and due to its very small size, it is called as a white dwarf. Now the temperature keeps on decreasing, but its size and mass, it remains unchanged, and thus the white dwarf is the end stage of stars which come in this group where their mass is less than 8 times the mass of the sun. Then second is the end stages of stars having mass between 8 and 25 times the mass of the sun. So these are bigger than the sun. How many times? 8, between 8 and 25 times. So how they end their life? Now these stars which are having mass between 8 and 25 times the mass of the sun, they also go through the red giant stage like the earlier one, and they increase in their size around 1000 times. And because of their huge size, the explosion which takes place is called as supernova explosion. And this explosion occurs at a very powerful rate, and a huge amount of energy is given out during the daytime also, which can be seen. Now the central portion of the star which is left behind, it contracts and it becomes very small, around 10 kilometers in size. Now in this state, the stars are only having the neutrons, and they are also called as neutron star. And thus the neutron star is the end stage of these stars which are having mass between 8 and 25 times the mass of the sun. So the third one is the end stages of stars having mass larger than 25 times the mass of the sun. They are much bigger than the sun. Now these stars, they evolve like the stars of the second type, which are having the size between 8 and 25, but after the supernova explosion, after that huge explosion, supernova explosion, the pressure is capable of balancing their huge gravitational force, and they continue contracting forever. They continuously start contracting, and as due to the contraction their size becomes smaller and smaller, their density and gravitational force increases at a very faster rate. And whatever objects are present nearby, they get attracted towards the stars, and nothing can come out of these stars, not even the light. And thus, if light falling on these stars does not get reflected and gets absorbed inside the sun, thus we cannot see these stars at all, but we can see a minute black hole in its place. So the stars which are having mass larger than 25 times the mass of the sun, they are ending in the black hole stage. So here is the summary. Initial mass of the star, if it is less than 8 mass of sun, then the end stage is the white dwarf. If the initial mass is between 8 to 25 times of the sun mass, then the end stage of the star is neutron star. And if the initial mass of the star is more than 25 times the size of the mass, then it ends in the black hole. Okay, so this was all about the star, students. With this we finish with the lesson, and thus in the next period we are going to start with the workbook exercise of this lesson. The workbook exercise of previous lesson is also remaining, so that also we are going to complete. But first we will complete the workbook exercise of this 19th lesson, and then we will complete the workbook of the lesson number 18. Take care.